Morning, guys. I'm Dave Canterbury with Self-Reliance Outfitters and the Pathfinder School. I drove the Jeep out to a wooded area today with several trees right here by a dirt trail. And I'm going to do some radio experiments today with antennas. And I brought my radio go bag out here, and I've been practicing with this, trying to get as far off grid as I can get with radio and try to figure out how to sustain that radio system over time. Different ways of using antennas for different applications. And to me, really, if I'm not learning something new all the time, I get bored. I'm too ADD for that. So I can't just concentrate on one area of self-reliance or preparedness for a long period of time. What I like to do is what I call immersion style training. I'll pick a subject matter. Like right now, I'm really in-depth studying ham radio and communications for emergencies. And I think that it's important in immersion training to understand that you just do it till you can't do it wrong. And the learning curve is very large for ham radio. So it takes a long time to learn that stuff. I've been at it now for several months, got my general license. I've done some videos along the way, and I like to do videos along the way as I feel more comfortable with subject matter, as I learn that subject matter better. I like to pass those learning experiences on to you. And some of the videos I make, people aren't all going to be interested in. Some of the videos I make are going to be more inexpensive type gear. Some of them are going to be more expensive type gear. Unfortunately, when you're talking about radio, unless you're talking about line of sight type stuff with a $35 Baofeng, most radio stuff is fairly expensive. And the more capability it has, the more expensive it generally gets. That's just kind of the name of the game when it comes to modern ham radio equipment. However, the capabilities of this type of equipment astounds me as far as what it can do and its versatility. And so some of the things that I'm learning now are ways to, number one, create antennas that will do more than one band. We'll talk about that a little bit. Create antennas that are resonant to a certain frequency that don't require tuners. And then how to manipulate those antennas to accomplish different things. And so that's kind of what I want to talk to you about today. I'm going to talk to you about a specific antenna today, how I've modified that antenna a little bit, taking some suggestions from guys like Josh Noss from Ham Radio Crash Course, the guy on YouTube, K8MRD Radio, I think is his channel, K8MRD. Yeah, I think that's it, K8MRD Radio. The Julius over in Finland. All of these guys do a lot of this more mobile type radio stuff. And the guy at Packtenna, George, who owns Packtenna, has been very gracious to give me information and send me a Packtenna to try out and work with. I've made some modifications to that, again, looking at some of the videos online. And I want to test some things today to include what's called NVIS, which is near vertical instant skywave. And to make that real simple in explanation, when you set up an antenna and you've got that thing well up into the air, or at least a half wavelength high, and it's a half wavelength long, and we've talked about that wavelength and how to figure those things in other videos, then you get a normal propagation signal from that antenna, which kind of, if you're looking at it, does this. So it goes out, bounces off the ionosphere a good ways away, and it comes back down in a curve. Near vertical incidence stuff is you're trying to make those signals go at a steeper takeoff angle so that they hit the ionosphere closer and come back down closer. So when you're looking at radio communications, you have line of sight radio, which is, across town with repeaters possibly to the other side of the state, maybe bordering states, areas close to the borders of other states, things like that. When you're talking about HF radio and ham radio and things like that, you're talking about a much bigger swatch across the United States, over the ocean, things like that. And when you're talking about NVIS or near vertical, then you're talking about that 600 mile radius where you could talk to possibly 2 states away, the next state over, the other side of that state, things like that. And the reason that's interesting to me is because, my family lives about 4.5 hours from here, which is perfect almost for NVIS, but almost impossible for any kind of line of sight radio, even with repeaters, unless you had a line of repeaters in that area. And you're not going to hit them on a normal HF antenna that's shooting way over the top of their head before it even hits the ionosphere to begin with. So I want to try to be able to isolate my signal to be able to do that NVIS and be able to reach Indiana on a ham radio. So those are kind of the things that I'm looking at, because I think in emergency situations, those type communications and being able to put your signal where you want it, that's very, very important. And then along with, can I create a bag of equipment that I can throw on my back and have communications without my vehicle, without the internet, without satellites, without my cell phone, just with radio waves? Can I communicate like that? And there are digital modes, like we talked about in the last video, like FT8 JS8 call, that you don't need any internet, you don't need any satellites. All you need is a simple software program into a computer, and it can encode, decode text over the airwaves using very little bandwidth. And the signal can travel for a very long ways because of the data ability that you have with things like packet radio. And it's a little bit more of an explanation than that, and I'm not real good at explaining some of that stuff, so I'm going to stick to what I can explain with you guys today. And we're going to talk about this antenna and the experiments we're going to do, so stay with me, guys. Okay, so this is my radio ruck, and in this bag on the front of the ruck is my complete antenna system for deploying an antenna. This is what I'm concentrating on. I want to be able to use this for nothing but antenna, and everything I need to communicate with an antenna is here, except the coax, which is inside the pack. So when you open this up, basically what you have is, right at the top, you have this EFHW half-wave antenna by Packtenna. And when you buy this antenna, you can see this thing's very small, very, very lightweight. But it is a great antenna when you buy it for the 20-meter band. It comes with one set of wiring on it for the 20-meter band and a 49-to-1 unnin. That 49-to-1 unnin that's on here actually matches the impedance of the antenna to the coax cable. I won't try to explain all of that to you because I'm not good enough to explain it to you, to be honest with you at this point. But what it does is it tries to match the resistance that is in the antenna wire to the 50 ohm resistance that's in your coax cable. And that's what that 49-to-1 unnin actually does for you. You should be able to take this antenna out of the box and take the wire and cut it down. It comes with about 40 feet of wire, and you need a little over 30 feet to be resonant on 20 meters. Once you get roundabout there, I would cut it a little bit long to begin with, and then I would kind of dial it in with some kind of an antenna analyzer or a tuner, or not a tuner, but an antenna analyzer or an SWR meter to get it where you want it. I've got this thing resonant on 20 meters at about 1.2 SWR the last time I checked it. We'll look at it today before we hook up the 40 meter element that I put on it yesterday. Then we're going to check out where the SWR is at on 40 meters. Then we're going to look at 10 meters and 15 meters, because you should be able to be semi-resonant on 4 bands with this antenna. You've set it up to be resonant on 20. I've set it up to be resonant on 40. However, there are the 10 meter band and the 15 meter band are basically harmonic with the 10 and 20 meter band. They're harmonics, so you should be fairly resonant on those as well. So in theory, you can get 4 bands in one antenna. We're going to test that theory today, first of all. The second thing we're going to do is we're going to set this thing up in what's called NVIS fashion that we talked about earlier, and we're going to put it about a quarter wave off the ground instead of a half wave off the ground to try to increase the angle of projection that our signal takes. And then we're going to look at things like PKS Reporter, and we're going to look at Grid Tracker on the computer to see where those signals are actually going to test that theory out. So this is the antenna we're going to use today, and it's the Packtenna EFHW half wave. Okay, so we know we have our Packtenna in there. In this pouch, we also have some throw line spooled up. It's just number 36 bank line. And we have a throw bag to throw that over a branch, just a normal throw bag you would use to put rope over a tree in forestry work, things like that, arbor work, things like that. Okay. I also have a small repair kit in here for the antenna. We'll talk a little bit about that when I talk about how I added wire to this, but I've got a couple extra banana clips in here in case one breaks, some shrink tubing and a couple extra clips, and I keep that in here as well. And then I have a small bag of different type connectors for the antennas and the antenna analyzer. A small pair of wire cutters to strip the wire. And yes, you could use a multi-tool for that, but this is going to do a much better job. It doesn't weigh very much. And then I've got a 2-meter antenna in here as well for my 705, and just a couple of flexible night eyes gear ties in here to tie things up if I need to. So these are the things that we basically need. So let's go and find us a tree, get this over a tree about somewhere between 12 and 15 feet high, and get this set up. Okay, I'm looking at that dead branch right there. That looks like it's somewhere between 12 and 15 feet high. It's a dead branch, but we're not going to put much weight on it, so we're not going to break it off, most likely. We'll take this throw bag, we'll unspool some line. Throw the bag over it. And that's where we're going to hook our antenna to, right there on that same area, okay? So this is the end of our 20-meter wire. And if we were just going to use the 20 meters, we'd string this up into the tree, and we would run it out and hook it up. And I'll show you that in a few minutes. If we were going to use the 40-meter, we would go from the other side. And when we get to the end of that, we're going to have a banana clip here that actually plugs in to this one. And there's a loop there that we can hook to this clip for stress relief. And that extends our wire to make the 40-meter antenna. So let's start off with the 20 and go from there. See where we're at on SWR. So all we're going to do is we're going to hook this clip to the bag just like that. And then we're going to hoist it up into the tree and take wire off of this Packtenna, which is just wrapped around a printed circuit board with that 49-to-1 on and on there. So we'll just let that sit for a minute, and we'll pull this up. And as we pull it up, we'll let wire off, just like this. Now we can stake this line down to the ground if we wanted to hold it up in the tree like that. But I've got enough slack here that I can just wrap it around the tree real quick, just like this. And I can probably just drop it over the top of this a couple of times, just like this. Come around one more time, drop it over the top, and then maybe loop it around one time. And that's gonna hold everything, and I have the tiny knots that way. And it's not gonna go anywhere from there. Now we'll just unwrap the rest of that 20-meter antenna and go back toward the vehicle. So we could tie this to a tree with some extra line, but we want to keep it a little bit off the ground. We don't want it sitting on the ground. I carry this electric fence pole with me because it's got a point on the end of it and I can drive it in the ground. Obviously, if you were operating out of a backpack, you'd be tying this to a tree. But because we've got this and it's convenient, we're just going to drop this inside here for now and drive this in the ground. Find this soft spot here to get that in the ground. There we go, like that. We don't need to have this extra tight. It just needs to be taut. Okay, so now we've got it hanging here and connected and stretched out. Our 40-meter element is still tied onto the Packtenna because we're only using a 20-meter element right now. Now we're going to hook a coax cable to our BNC, check our SWR with an antenna analyzer, and then we can start experimenting with things. All right, so the way this pack's set up, this coax cable goes right here in the mesh pocket. I've got a bag here that just rolls up and sets in the top of the pack above the radio that actually has my microphone and my antenna analyzer in it. I also have a DCF bag here in my antenna bag that's got some adapters in it. We're going to need some adapters for this because the first thing we're going to need is we need the front end coax adapter for this antenna analyzer. And then we need an adapter that will allow us to connect a BNC cable to this, just like this. So we put two adapters on the front of this, and now we'll be able to plug our antenna feed line or our coax cable into the front of this to check and see what our SWR is. All right. Okay, so now we're plugged into our coax cable, which goes to our antenna. We'll get this thing turned on, and we will get it set up for the 20-meter band. So we're going to hit set, and we need to change this to 14,200 for the 20-meter band. 14,200, Set. Okay. You can see our SWR is standing at 1.6, 1.5, 1.58, 5.9. That's definitely doable SWR. No worries with that. It's probably a little higher because we have the antenna lower than it normally is. I think I had it at 1.2 when I originally set it up. But anything under 2 is plenty operable, okay? So we're going to call that good. Now, the next thing I'd like to see is, what does it say about the 10-meter band? Because remember, we talked about harmonics. That 20-meter antenna should be operable on 10 meters, and we shouldn't need a tuner. That's what we're going to test right now. All right, so now we're going to change this to 28,500, which puts us about the middle of the 10-meter band. SWR is 1.35. Excellent. So now we definitely are resonant on 10 and 20 meters, enough that we can communicate without worries. We don't need any kind of tuner whatsoever to do that. We're ready to rock and roll. So now with this NVIS setup, let's get on 10 meters and see what our signal report looks like, punching some FT8 or JS8 call out onto the airwaves and see what we get. Okay, I realize that you can't see any of this, and I'm not real good at flashing computer screens over my videos and all that kind of good fancy stuff. I'm not that fancy. However, I will show you some photographs of grid reports and things like that on 10 meters. Okay, so I switched over to 20 meters from 10. I only had 2 spots on 10 meters after about 15 minutes. They were both down in Virgin Islands area. But the band had almost no activity on it. As soon as I switched to 20, I started getting lots and lots of spots and decoding a lot of stuff. I know you can't see this very well because of my phone. I apologize for that. I can see my own reflection in the phone. Maybe if I move my arm out of the way, it'll help. But you can see I'm getting spotted all over the United States with that 20-meter antenna. Even at that low angle of probably 15 feet high in the tree, this thing is still, shotgun blasting the entire United States. And we'll see if it goes overseas or not, but it probably will. If it's hitting that close to the edge of the U.S., down Florida and clear up there in Washington, the chances are it's going to go overseas too. So we may have to go at an even lower angle, or 20 meters just may not be the right band, and I don't think it really is. I think those bands like 10 and 15 are better. I also think they're better at night. So we're going to let this run for a few minutes, then we're going to change this thing over to the 40-meter element and test 15 meters and 40 meters. Okay, I'm pretty sure that 10-meter band is a nighttime band. It's better to be on that at night. I did have 2 pins, 2 spots. Both of them were in the Virgin Islands. Now, I had one showing up on my DX map, or my, on my grid tracker map, Kentucky. That's the first one that showed up, but then it disappeared. When I pulled up the PSK report, it didn't show the one in Kentucky. It only showed the 2 in the Virgin Islands. So we've got the antenna set up at about 15 feet high, which is much less than a half wave. And we're set up on the 20-meter element. We're resonant, we know, on 20 and 10. We've tested 10. I'm now put 20 on there. 20, I'm getting lots and lots of spots all over the U.S. So we're still not getting that NVIS that we really wanted because we're way out there. I'm hoping that I do get some spots closer in. We're going to find out over the next 10 or 15 minutes, or whether it's just a shotgun blast all over the U.S. And then we'll go to the 40-meter element, and we'll look at 40 meters, 15 meters. Part of the problem with 10 meters was, like I said, very little band activity on 10 meters right now, probably a nighttime band. 20 meters is going to be loaded during the day. So that's going to give us a good indication of where our signal's going, and if we're actually getting anything closer in, or if everything's way out there still. All right, something really cool happened. It's kind of a learning lesson. And I wish I could show you this on my computer screen, but there's no way you're gonna be able to see that, and I'm not fancy enough to plug it into this video. However, I can take some screenshots and show you some of that stuff later. Here's what happened though. I'm using Grid Tracker. Grid Tracker actually does a couple things. Number one, it'll give you a little list at the bottom of the screen. It will tell you who's on the air, and it has their call sign and what state they're from. It also shows your signal track as you send out a message or a QSO. So I saw a guy come up in Illinois, and I got all excited about that. I thought, hey, if I could talk to this guy in Illinois, that's going to prove that I can do NVIS from, this 20-meter antenna. So I double-clicked on that guy to do a CQ, and that signal went clear out to California. What that tells me is there's a guy whose call sign's registered in Illinois who's operating in California. I would not have known that without Grid Tracker. If I had contacted that guy somehow, by chance, and logged him into my QRZ log, I would have seen that he was from Illinois and assumed that I was talking to someone in Illinois and been confident that I was getting a little bit of NVIS action during the day on 20 meters, when in fact, I didn't. So there are lots and lots of pluses to some of this programming that you can use on your computer to see what your radio is actually doing. Okay, so we let that thing run on 20 meters for a little while, and I took a screenshot of the PSK reporter, and you'll see that it's out here. It's not in here where I want it to be. I didn't expect it to necessarily be on 20 meters. That's kind of a band that you tend to use if you're going to hit far away. Close state I got was 3 or 4 states away, so it's not what I'm looking for. Now what we're going to do is we're going to add the 40 meter element, check the SWR, then check the SWR on 15 meters, and go to 15 and 40 and see what happens with the same height setup of our antenna. Now, once we add that extra wire, it's going to give us a little bit lower angle than what we've got with the 20, because the longer that wire is, the more it's going to kind of decrease that angle coming off the tree. So hopefully that gives us a lower angle and a better NVIS signal. See what happens. Okay, so I've lowered this down, and I'm going to take this clip off that's got our 20 meter element and our little pigtail for connection on here. And I'm going to, this wire's black so it's hard to see. And now what I'm going to do is I'm going to take the other end of this 40 meter element and I'm going to hook it to the bag instead. So I'm going to take this one, I'm just going to clip it right to this line and leave it laying right here for a minute. This is the one that came off of this is our 20 meter element. Now I've got our 40 meter element here. And this one needs to go up into the tree. So I'm going to unwind this enough to lay it on the ground here and take this clip and clip it to our bag, just like this. Okay, now here's the end of our 40 meter element. So now what we're going to do is, remember it's in the tree. So we're going to take this off of here and we're going to connect these two banana clips together just like this. You can hardly see those bad boys. And connect this to this clip just to give us a stress relief point so that when these are pulled, it's not pulling on that connection. And now we're going to stretch this wire out and readjust where we're at. And we'll have a 40 meter antenna that should be resonant on 40 and 15 that we can check. Okay, so now we're clear across the road. We were on the other side of the Jeep. Now we're clear across the road from the Jeep. And we're set up. We'll get our coax plugged in. We'll see where we're at. Okay, first thing we want to do is we want to plug into our antenna analyzer. And we want to check our SWR on 40 meters. So, turn this bad boy on. I'm assuming you can see that. All right, so let's go to set 28,200. That'll be about middle of the band. All right. 2.3, that's pretty high SWR. That's actually a problem. We need to change something on that. So yesterday I had that thing down well below 2. Today it's showing 2. Now that could be because of our angle, our height. I'm not sure, but our wire is actually too long. So we need to make our wire shorter. One way to do that, unfortunately, is to lower it from the tree and make that line shorter than it is. Okay, this is really good because I just set this 40 meter element up yesterday and I had the thing below 2 SWR yesterday. Today it's at 2.4. So what I want to do is I'm going to pull the stake back over to loosen the antenna up. I'm going to drop it down, and I'm going to take up some more line in that hook. I've left it long on purpose and just wrapped it around. I'm going to pull some more line off of that, or pull some more line through that hook to shorten the antenna electrically and bring that SWR down. That's part of the game. That's why an antenna analyzer is a good thing. I could have assumed yesterday I had it right. Today it would have sucked. So let's look at it, see if we can get it right and get it dialed in, and then we'll look at 15 meters. Okay, so what we're going to do is we're going to pull this hook off this weighted bag. And you can see that I've got several wraps in here, and I've got some line, extra line right here, extra wire right here, where I've taken up lengths to make it shorter. Now you can measure this, and there's nothing wrong with measuring. However, I'm too impatient for that. So, and I don't want to carry tape measures around the woods. So I'm looking at that SWR and I'm saying 2.4. I'm saying this wire's too long in that frequency. So what I'm going to do is I'm going to take this wire and I'm just going to choke up about 6 inches out of whack. I'm going to pull a loop in that thing, and then I'm going to feed it through, just like that, and make that line shorter. Okay, that didn't buy us a whole lot. Didn't buy us hardly anything at all, actually. So we'll go another 6 inches, see what happens. All right, so we've got this down to 176 right now. I could tweak it a little bit more than that, but I'm going to call that good for this experiment. I may tweak it a little bit later. And now I hesitate to tell you exactly how long that extension wire is, or exactly how long this antenna is total for this end-fed half wave, because I think there's a lot of variables involved in it. You can do the formula, figure out where the center of the frequency is-ish, so 7.200, and divide 468 by that 7.200, and it will give you the length in feet approximately the antenna should be. And then you're gonna have to tune it from there. And the reason I tell you that is just because I've done it a few times now, and I've found out that the actual measurement's not perfect. And I actually took the measurements from Cade MRD Radio's video, and I used them in the beginning to get my wire set up on the 40 meter, and it was actually well longer in his video than I needed as far as his measurement goes. So I think a lot of that has to do with, you know, the terrain, the location. I don't know. There's probably a lot of variables in there, but I've never found a formula that hits it dead on. You cut the wire to that and it's perfect. You're always going to have to tweak it some, and I think that's why the guy at Packtenna gives you that 40 feet of length pretty much, when he knows that you're going to have to go down to the 30s with that thing to get it resonant on 20 meters. So I played with it enough to get it below 2, and now we'll check it, and we'll check 15 meters first to see how resonant we are there, and then we'll go to playing with the radio and see what we can do on 15 and 40 as far as NVIS goes. Okay, so they say by doing this, you should be resonant on 4 bands. We checked with the 20 meter antenna, it was resonant on 10. So that gives us 2. We know we're resonant on 40 now, close to resonant. So that gives us 3. Now we want to look at 15. So looking at the band plan here for the 15 meter frequency, we need to set this thing to about, we got 21,275 to 21,450 for general. The data is going to be lower than that, but what we'll do is we'll pick about 21,300, 325, 21,325. We'll see where we're at. So we'll get this thing set up. We'll get our rig expert set up here to check 21,325. 5. Now let's just verify real quick that we're right. Looking at our band plan here, 15 meters. 21,325 should put us close to the center of the voice or phone band for 15 meters. Nice. SWR is 1.78. It's actually less or more resonant on 15 than we are on 40. So that tells me I want to leave that 40 probably alone, or maybe just tweak it a little bit. So now we are resonant on 4 bands with this single antenna. So we've got this single small package that gives us 4 bands that we're resonant on that we can communicate with. Some are better at night. Some are better for NVIS. Some are better for, you know, worldwide type saturation. Some are better for closer up. So let's check and see what 40 does for us first. Then we'll go to 15. Okay, this looks encouraging. Spots are coming up and they are close. We actually have a spot in Indianapolis, which is exactly what I wanted. And we have one down in North Georgia. So far, so good. All right, so I've got this computer screen shaded a little bit with my body here, and you can see this guy that I talked to in red. That guy's from Indiana. And if you look at my propagation report, it's a whole lot different than it was on 20 meters. Now I'm trying to hit a guy in Michigan. But you can see my spots are all way more centralized now and closer to me than they were with this NVIS setup on 40 meters. There's a lot of band activity, it looks like, on 15 meters right now. So we're going to switch over to 15 meters here in a few minutes and see what happens there. Okay, now I'm talking to a guy who's in Michigan. So that's Indiana and Michigan I've hit so far. You can see there's my signal. Just got finished with that conversation. It's asking me to auto log. Let me hit that. Get that out of the way. You can see the signals right there going back and forth Michigan. So that is awesome. I would call that experiment a definite success. All right, so here's a guy in Western New York that I'm hitting right now, up by the lake. See him right there? That's 3 really close contacts, Michigan, Indiana, and Western New York. I'd say this NVIS experiment on 40 meters is a success. Now we'll try 15. Okay, on 15 meters, you can see our first contact is way out there. And we got a couple spots way out there too. So 15 meters, even on NVIS, or at least attempting to set up NVIS, and it may have to be lower for 15 meters, hard to say, but we're still hitting out west. The best luck we had was close, was on 40 at less than half wavelength in the air. So all these things are things you make notes of and you mentally remember so that you can use them in the future. But 15 meters, made contact right off the bat. Okay, so not exactly what I was trying to accomplish. However, lesson learned, talking to a guy right now in Venezuela, okay, on 15 meters. Again, wire in a tree, 5 watts, talking to Venezuela. And there's the end of the conversation, asking me to log it. There's the guy's call sign, lit up me talking to him, Venezuela. Freaking awesome. Now this 15 meter band is a DX machine with this antenna. I was just talking to Cuba right there. Guy in Cuba. Right there he is, Cuba. Again, wire antenna right there. Going up about 12 foot high into a tree. You can see the red bag hanging off the tree right there. That's how high that antenna is off the ground. Coming back down here, right back across the road. Right there's the end of the Packtenna. Okay, so while I'm out here, I want to try one more thing. What I want to do is, I can see that 20-40 meter element connection from here, and I can reach it. It's only 6.5 feet off the ground with that slope coming off that 40. If I disconnect those and leave the clip on there, then the only thing that I'm going to have signal going from the coax to is that 20 meter length at a much lower level, that 10 meter length at a much lower height. So I want to experiment with that a little bit and see if I can set the 40 meter antenna up and then again, play with 4 bands without having to take it down, set a second element up, just disconnect them and start talking on 20 and 10. Let's try it. Well, here's another example. This guy's call sign says he's in Wisconsin, but I'm talking to him in Florida. So he's probably a snowbird and he's living down in Florida for the winter. But that's the kind of things that this program, this grid tracker program, can tell you. And you can see I'm getting that wide splattering again of spots all over the U.S. There I am talking to him again. That I was getting on 20 meters earlier, even with that antenna only 6 feet off the ground. The radiating element is only probably 6.5 feet off the ground at the very end. And I'm still getting pretty good coverage in the U.S. with that thing. So I don't have to be really high in a tree for that thing to work either. So I'm about ready to wrap things up. My experiments, went pretty well today. And so what I learned from this was that even at less than a half wavelength in the air, which was attempting to be an NVIS type situation, and maybe I'm not low enough yet. Maybe that's the problem. But I had that reading element for 20 meters, only about 6.5 feet off the ground in the end. And still was pumping clear out there to Florida, California, as far as spots go. So 40 meters was our best bet today. That was our closest contacts. Indiana, Michigan, Western New York. That was really good. But 40 meters is 40 meters is a closer band anyway. It operates in a closer area than 20 meters does. It's not like a big shotgun blast out like 20 meters is. So I don't know whether I accomplished an NVIS scenario on 40 meters or that was just a lay of the land. I'm sure somebody on here can tell me a lot better that'll comment on this video. However, I did find out that this antenna is now resonant on 4 bands. I found out that I can set it up for 40 meters and just disconnect and still operate on 40 and still operate on 20 and 10. And then I connect it up and I can operate on 40 and 15 as well. So I do have a 4-band resonant antenna now in a very, very small package. All right, guys, well, I'm Dave Canterbury with Self-Reliance Outfitters in the Pathfinder School. And again, a lot of these videos are just kind of a day in the life. What am I doing today? Well, today I'm going to go out and experiment with some antenna stuff, try some radio stuff, see what works, what doesn't. Because doing it close to a vehicle and finding out what's wrong and fixing the bugs means that now I can walk away from the vehicle and do the same thing. So those are next evolutions, is taking this stuff out, doing it overnight, spending 24 hours out there and see how this equipment runs over a 24-hour period. I just got done doing winter field day. I ran for probably 12 solid hours on nothing but the PowerFilm Lightsaber Max, charging both the laptop and the radio back and forth, and then collecting sun as I went to charge that 12-volt battery in the Lightsaber Max. Great piece of kit. I'll do a review on that. We'll talk about that in a future video. But for now, I just wanted to take you guys with me while I checked out this Packtenna EFHW half wave, added some material to it to make it resonant on 4 bands. So it was a 20-40 meter antenna, resonant also on 10 and 15, respectively, and take you guys along for the journey. I appreciate your views. I appreciate your support. I thank you for everything you do for our school, for our family, and for our business, for all of our sponsors, instructors, affiliates, and friends. And I'll be back with another video as soon as I can. Thanks, guys.